Okay, so we're going to go over projectile motion using calculus. Alright, so let's go over a projectile motion example. Okay, so we fired a projectile at 1.5 meters above the ground with an initial velocity of 100 meters per second and an angle of 30 degrees. So I'm just going to draw like the simplest picture over here. So let me grab my pen. I'm going to set my origin to 0 and make this negative 1.5 meters. And this is y and this is x. Pretend this is straight. This is supposed to be straight. Okay, and so let's take one of our kinematic equations and solve for the time it takes for the final range. So when the projectile is basically hitting the ground. Okay, so we're going to do it in the y to solve for t. Okay, so we need to write down some of our knowns and unknowns. So we know that y initial equals 0 based on our coordinate system that we set. And then we know that y final is going to be negative 1.5. And our v initial is going to be the 100 meters per second multiplied by cosine of 30 for the x and sine of 30 for the y. And then our acceleration in the y equals negative gravity. And we always know that our acceleration to x for projectile motion equals 0. Because there's no acceleration to x. It's only due to gravity. Okay, so let's continue solving for our time. So y of t is also y final. Keep that in mind, because when you plug in our time, you get the y final. So we're going to go negative 1.5 because we know it's going to end up landing 1.5 meters below where we're standing. So in this 0, so v0y is going to be our 100 meters times our cosine of 30. And then we just write t plus 1/2 of, we're going to use the 9.81 for Earth, so, and it's negative, so 1/2 of 9.81 is negative 4.9 t squared. And if you look at this, this kind of looks like a quadratic. We just have to move some things around. So negative 4.9 t squared plus, so 100 cosine of 30 is just 50, so we'll do plus 50t plus 1.5 equals 0. And then remember the quadratic formula, which is this. I'll write it up here, negative b plus or minus the square root of squared minus 4ac all over 2a. So I just plugged that into my calculator, and then I got that it's plus or minus negative 0.32 or positive 10.234. But we're not going to bother with negative times, so we're just going to take the 10.234. So now we have our time. So what we need to do to get our range is we're looking for the x. We're not looking for the y up here, we're looking for the x. So we just need to plug it into our x of t. So let's use another kinematic equation of x of t equals t initial plus v0 x tangent t plus 1/2 ax tangent t squared. So if you noticed right away that ax equals 0, so this whole thing goes to 0. Our x initial is also 0 based on where we set our coordinate system, so that can go to a 0. So all we need to do is plug in x of 10.234 equals, our v0x is going to be 100 cosine of 30 degrees times, now plug in our t value, which is 10.234. And then I'm just going to put that into my calculator real quick. It's going to be, we're going to be about 86.29 meters away for our range. Alright, hope you enjoyed, and that is the end of this video. Thank you for watching.